submit later today, but we will be able to do as much as using the SPSS and a kind of application into real estate. I've come out with a data that I've captured in SPSS that will show an application of statistics in real estate. So shortly, in another 4 minutes, we will start. And as much as we can go before I can leave the class for the review exercise. Is that okay?
Yes.
Thank you. So I will show you my SPSS data. We will begin to manipulate and to do analysis from there later. I'll be right back.
Doctor, we can't hear you.
Doctor, you mute your mic.
Good afternoon once again. Right, I'm back. So, well, last class we talked about using SPSS, the various steps in SPSS, capturing the data and performing analysis. Today, I've tried to come out with some information that we can input it into the SPSS and try to use it to do some analysis and try our hand on regression analysis. So the data I've put together has to do with rental value of properties, and I inputted some data about the location of the property, the access, whether the access is good or fair, as well as the size of the unit. So let's take it for a residential accommodation. I think I can start, okay. I can start to share my screen so that I will be moving from my screen. I share my desktop, so we move from one application to the other. I guess you can see my screen now.
Yes.
Okay, so we're staying in class. The information I gathered, as I was saying, is about the rent, the location of the property, and I just choose few locations like PJ, Damansara, Pantai, Bangsa. So just an hypothetical case. So also, I try to compute distance, a kind of how many kilometers from the place of the property to the central area. So then I try to look at the accessibility, how good it is, good or fair, size of accommodation, then the level of facilities or services in the property, and the state of repairs. So what I want to bring out is that we can find a regression to know what is the contribution of all these variables or elements on rental value determination, so that we can be able to say if the distance is so, this so much, or this so less. So this is a typical way of using SPSS in real estate business analysis, so that you can be able to predict, if you know the distance from the central area to a property location, because of the information at hand, we can be able to predict and say, oh, rent will be in so range in that an area. So this is the essence of getting this kind of information, which is typical in real estate business. This information like this with more variable can be used for mass valuation, where you can compute valuation in similar areas. Once you know the distance, the size of the accommodation in square meters or square feet, and once we know whether the state of facilities, how good is facilities there. So this information have been captured. So I show you my SPSS now. So this is the data, but I want to start from the data view, from the variable view. Here, these are the variables that I've put together. I think you can see it very clearly. Rent, yes. Location, and the rent, that is the monthly renter from the property. That's the label. Location is about the property location. Where is it located? Area. Distance, I try to compute a distance from the CBD, and we can even take it, say, distance to UM. If you take UM to be the central place, we can say distance to UM. Then I look at the accessibility. The accessibility in terms of how fair and how good, how motorable, how easy you can locate the place. Space in square foot. Services, whether it is fair, whether it is excellent, whether it is good. State of repairs. I put the tenant gender, male or female, and I put some a kind of nationality, maybe Asian, African, others. That is how I've categorized this. So, and that's what I put as race, whether if you are from Asia, you are from Africa, or you are from the Western world, others. Then when we look at the values inputted, and we look at the measure, we say we can have scale, we have scale there, we have nominal, we have ordinal. Scale means measures. It's continuous variables. Like rent can be from 0 ringgit to billions of ringgit. So it's continuous, it's a scale. In terms of location, because no location is better than we are not saying one location high is more better than the other. We just want to differentiate from where these properties are located. And that is why we say nominal. It's just a nominal. We just want to differentiate where the property are coming from. We are not really keen whether the location is better than the other or not. So they are equal in order of goodness, but their physical presence differs. Then we look at the assets in terms of fair or good. Fair or good, we know that good is better than fair. But the only thing is that we cannot take the measurement of the difference. So to show that one is better than the other, we have used ordinal measurements. So SPSS now understand how these variables have been measured. Now we go to our data variable. So on the data variable, for example, the line 1, where we have rent, the rent is 750 RM here. The location is number 1. So what I've done is that location PJ is 1. Location, okay, let's look at it at the variable view. The location, here I say location 1 is PJ, 2 is Damansara, 3 Bangsar, and 4 Pantai. So this is how I've classified my location here. And when we go to data view, that's why you can see 1, 2, 3, 1, 1, 1, 2, 2, 2, 3, 3, 3, based on their location. In terms of distance has been measured in kilometer. So we have a place that is 4 kilometers to the center, 2.3 kilometers, and so on and so forth. We have tried to measure the accessibility in terms of how good or bad it is. Some are good, some are fair, some good, fair, good, fair. And in terms of size, I've used square meters. So I measure the space in square meter. And this has been the sizes. And I think the biggest size is 105. So forth, so on and so forth. Then the facilities have been ranked, whether they are fair, 1, good, 2, and excellent, 3. So if you have excellent facilities in terms of services such as swimming pool, play area within the location of the property, those services are available. So sporting or recreational facility around. So we have excellent, good, and fair. And in terms of state of repairs, we just choose good or fair because there's no property that is not maintained. The only thing is that how good or how fair is the extent of maintenance. Then with gender is either male or female, 1 for male, 2 for female. And in the race, I've chosen 1, 2, 3, Asian, African, others. So from here, we can begin to do our analysis. And when we get to analysis, we can start from descriptive, I think. So, for example, normal distribution, if we want to test how normally distributed your data are, we can try it in our analysis. We can select all those information. So let's go for descriptive statistics. Now, part of the descriptive statistics is defining the mean, the median, the mode, frequencies, and as well as standard deviation, and we can get the normality done. So I start with descriptive statistics. So we analyze, and we go to descriptive statistics, frequencies. If you want the frequency count, all the variables we want to be counted, we will put it here. So I can get all these variables from here. All these 9 variables and put it here. So I want to do my descriptive statistics on all of them. Number 1, frequency table has been selected. Then we can do more by clicking on statistics. So we get mean, we can get median, we can get mode. If we want the sum, we can get standard deviation, we can get minimum number, maximum number. We can get variance, we can get range. As much as you select, SPSS will give them to us. Then, in terms of the distribution, we can use skewness and kurtosis to see whether our data are normally distributed or not. So we know which one is normally distributed, which one is not normally distributed. So we can say continue. If you want to put in charts, we can look at chart builders and select maybe bar charts. And if we want the percentage distribution to be on the charts, we can either select percentage or the frequency. Then we say continue. Click OK when you are ready. OK. So the SPSS has processed it and is giving us our statistics table. The first table, statistics, here, we can all see missing data, no data is missing. That means every data is computed. And we have total number of 50 entries. 50 entries. So let's look at the mean. For the monthly renter, we can see the mean. And the mean is 1,836 ringgit per month. That is the mean renter. For the median, is 1,800. For the mode, is 2,500. That means 2,500 appears highest number of times. So from here, these questions has been of descriptive statistics. We have variance, we have standard deviation. The standard deviation from the income is 585. What this means is that from the mean, right from the mean, the range of the income fall between 1,836 minus 583 to 1,836 plus 583 plus SD. So within that range, you will know how many of these income range that fall within the range. So to know whether the distribution is normally distributed, we can look at the kurtosis values or skewness values. I'm not sure, I don't know whether you are seeing the values, if it is not too tiny for you. I hope you can see them.
Yeah, we can
Okay.
see them clearly. We can see, Doctor.
Okay, fine. So we have various values between the skewness across the row. Now, for normal distribution, statistically, the skewness or the kurtosis you fall within minus 1.97 to plus 1.96 to plus 1.96. So for any variable that the kurtosis is outside this range, it is not normally distributed. So when we found our normal distribution, look at this. If the skewness value is greater than or plus or minus or less than plus or minus this is 1.96. So that means the ranges fall between minus 1.96 to plus 1.96. So between minus 1.96 to plus 1.96, if the skewness or kurtosis value fall within that range, we will say it is normally distributed. If it is outside, either to the negative side or to the positive side, we say it is not normally distributed. So let's go and look at our values. So here in the output, let's look at the skewness first. The skewness, the first one for the income is 0.242. Can you see that? I'm on the monthly renter now. The skewness value is 0.242. I think we can see that.
Yes.
And seeing that, we will know if you put it between minus 1.96 to plus 1.96, you will agree with me that this value fall within the range, right? 0.242 is less than 1.96, and it is greater than minus 1.96. So with this value, we'll say the distribution concerning the monthly renter is normally distributed. So this is normal distribution. I will tell you why we want to know whether it is normal or not normal later. So let's go on and look at all the ranges for the skewness. The property location is normally distributed to 0.575. Distance to CBD equal, which is 0.076, and 0.076 is still less than 1.96. For accessibility, we have minus 1.7, and minus 1.7 is still greater than minus 1.96. So we will say it is normally distributed. So we look at all that line until the end. Which one didn't fall within? All of them fall within the range. So our data is normally distributed. Did you understand that? How we check normal distribution?
Doctor.
Yes.
I have one question. The 1.96 is fixed already.
One plus or minus 1.96 is fixed. So your value will fall within the range.
Okay. Thank you, doctor.
So if it is outside the range, then it is not normally distributed. If it is within that range, it is normally distributed. So if we go by skewness, we discover that all our variables, the data collected for the variables, if you look at this skewness, that means normally distributed. The way it's skewed is not too much one extreme end or the other. Now, we can check the kurtosis too. So the kurtosis, when we start from income, is still within the range, minus 0.29. This one is minus 1.02, which is still less greater than minus 1.96. And when we get to minus 1.814, which is still less than minus 1 point, which is still greater than minus 1.9. So with these kurtosis figures too, we will also agree that the data were normally distributed. So these are the two ways of checking normal distribution. Now, why do we check normal distribution, whether it is normal or non-normal? We check this so that we will know whenever we want to do analysis in SPSS, we will know whether we are to do parametric test or non-parametric test. Parametric test is for normally distributed data. Non-parametric test is for non-normally distributed data. So this is why it is good to check for the normal distribution when you do our descriptive statistics. So having said this, we agree that this data we are using today is normally distributed. But if peradventure there is a particular data that is not normally distributed, we can use non-parametric test. Again, when we are doing any analysis that has to do with ordinal data or nominal data, that has to do with categorical data, it is advisable that we use non-parametric test. So we'll see more as we go. Now let's check our frequency table. This is the statistics that we have asked SPSS to do. And leave here, before I leave here, let's check, we ask for range, we ask for minimum, and we ask for maximum. For each of the variables, the minimum entry for the data or the maximum will be displayed accordingly. Here, the range of income is 2,250, which is the minimum minus the maximum. 750 minus 3,000. 3,000 is the maximum rent in our data. In terms of the location, the maximum is 4, 1 to 4. So we have 3. So when we get to the square meters, that is the size of the space, we have a range of 60, when we have minimum 45 and maximum 105. In terms of space, how big the space are. And so these are the way an SPSS will give you statistics of everything, and you just need to pick the numbers you need for your interpretation and discussion. I hope this is clear.
Clear.
Any question? Any question?
No question.
Okay, so no question about this. Good. So let's check other outputs that SPSS gave to us on this analysis. We have frequency table, okay? So from here, from the frequency table here, we can quickly see how many of our respondents are paying certain amount of money. So we quickly see how many are paying this kind of amount of money. For example, you can see our mode is 2.5. So 8 people out of our entry are paying, their rent is about 2.5. Some are 2,000. How many people are paying the highest rent? We have 4 people paying the maximum rent of 3,000. And we have 3 people paying the minimum rent of 750. So you can quickly see the distribution for each of our factors. Here, about location, we can quickly know how many people are living in Pitalinjaya, how many people are in Damansara, how many are in Bangsa, among our respondents. So this quickly gives us the distribution. Then when it comes to distance, we quickly know how many people are so far or near to the central business district or to the campus. So this distribution will tell us how far are people living from the center of activities. And then we look at how many people have their accessibility to their area to be good or fair, how many people have good services or excellent services we can get. In terms of space per square meter, we can quickly see through this frequency distribution how many people are having a large space or small space. So that if you look at the number of the space, for example, supposing this data contain the data of how many people are living in each accommodation, we will quickly see how many people are living in an accommodation that is so big or so small, or an average number of people that are living. So if you put number of household, we can always get how, so that we will know whether the houses are congested, overcrowded or not. And that can help in a decision for housing accommodation, whether we know that some areas are overcrowded or not. I hope that is clear too. So all for all this table, and if you once you have chosen a bar chart, the bar chart are equally provided on each one for the monthly renter and all the variables we have inputted. So we can look and see how they are distributed. It means in the area of nationality, it means more Asians are respondents in this chart. And you can see from this, this is about 34 or so out of 50 respondents. So I think this is a fair distribution anyway. Now, let's do another important analysis that we can, because we are relating this to real estate straight away. Yes. 2.7, why is this there? Okay. Then we go back to our data. And we have checked the distribution, we have done for normal distribution, we have done this. Okay, let's hypothesis. For example, in an hypothesis, let's say from our data, we have an hypothesis that location, for example, that let's say distance does not affect rent, or location is not affecting rent, or we want to check relationship, which is a correlational studies. So we can do correlation for all these items from rent to the race. And when we get our correlation, we now look at the correlation table one by one and see what is the relationship between one factor or the other. So I proceed to check that relationship to know what is the relationship between all these assets. And when we do that, we analyze again. Everything we want to do in SPSS start from analyze. So let's then correlate and bivariate here so that it can give us this time. We want to correlate all these items against each other. Yes. So correlation, yes. So since our data is normally distributed, we will do per scene, which has been selected. If there is an item that is not normally distributed, we may choose Spearman row. So we can go and do the two, because some rank factor, so that we can see the difference, if there is any difference between the two. Just for a check, we can do per scene, we can do Spearman row, because depending on whether it is ranking data, parametric or non-parametric. Let's see the options here. Here we have said at two-tail, SPSS should flag significant correlations. So SPSS will flag it for us if there is significant correlation. Options, then we need any other options. Oh, this is means and standard deviation. We have checked the means and standard deviation during descriptive. So we don't need this anymore. So we can say continue. Then we click OK, since we are ready to run the correlation. And when we do correlation, you can see this is non-parametric. So we are choosing both parametric and non-parametric. So the first correlation here is parametric. That's why you say Pearson correlation. So because our data is normally distributed, it's a parametric analysis. Let's check the correlation. When you want to check correlation on a table like this, first of all, look at where you have 1, 1, 1, 1 diagonally. So if you want it to be clear, from this diagonal distribution where you have 1, 1, 1, 1, 1, you can delete all other factors at this end. But 1, 1 is showing when a variable is being correlated with itself. So correlation will always be 1. When a variable is being correlated with itself. So let's look at monthly renter, correlating monthly renter. That's why you have 1. And that's a perfect correlation. Normally, if you are correlating item against itself, it gives you a perfect correlation. Look at property. When property location is correlating property location, you have 1. When distance is correlating distance, you have 1. So that is the boundary line for us to delete one side so that we concentrate on looking at the other side. So as in the class now, let's just believe we are not looking beyond this diagonal 1, 1, 1, 1, 1. Now, let's check monthly renter with property location. If you check monthly renter and property location, you will see that there is a negative relationship between the location one is increased when location, the distance increases, the monthly renter reduces. That is what the implication is. As the distance increases, your monthly renter reduces. However, in this analysis, it was not a significant relationship, but it is what is seen that relationship between monthly renter and property location is an inverse relationship. So when you experience when you want your renter to come down, that means the location is longer. If you are expecting a lower rent, then you have to go further. You have to go further from the central. That is where you can get a renter that is lower. So the longer the distance, the lower the rent. I think that is understood. Class, do we understand that?
Yes, yes.
Okay, again, let's look at this one that is talking about which is significant, because I want to explain this one that is significant. This is distance to CBD with what? With property location, okay? Distance to CBD to property location. I want to explain this. Property location, we are talking about the neighborhood. Distance to CBD. If your distance to, that means the more distance, the farther you are away from the CBD, then the longer the area of your location. Here we have selected some areas, CBDs, Amansara, and it shows that once you are far away from CBD, you are getting farther from this. If you have a closer area, your choice area is Pitalinjaya. If you are in Pitalinjaya, then you are closer to the CBD. That is what it's saying. The location we have selected, we know we have selected Pitalinjaya, Bangsa, Damansara, and what is number 4, Pantai. So here, what it's saying is that the choice of your location, that it shows how your distance to the CBD will be, and that is a significant relationship. Significant in the sense that if you go to a particular location, you are going far away from the CBD. So I wouldn't know whether, I think Pitalinjaya is, if you are choosing Pitalinjaya and I think PJ seems closer to So if that is correct, that means your choice of location will determine your distance to the CBD, and that is very, very crucial. So if your distance to the CBD is far away, definitely it will affect your monthly rental. But showing that it is significant, you see it is flashed. And as I told you about the p-value, we will discover that the p-value is far, far less than 0.05. And that shows significance. We can look at some other, another one that we can look at is the state of repairs. When you look at the state of repairs and monthly rental, so it means there is a positive relationship, which is significant. What does this say? This is telling us the better the services in a place, the higher the rental you pay, which is, I think this is expected theoretically. If you have enough services wherever you are staying, then you are going to pay more. So the standard of services or facilities you have where you are determines how much you pay, and it's a significant factor in rental determination. So if you want to determine rent, you will look at whether the area is excellently serviced. If it is excellently serviced, then the rent is expected to be higher than the average. So also with the space too is significant, and that shows that the bigger the space, your accommodation, the more you pay. This is expected. If you are occupying a bigger place, you have to pay more for the space. Now, what does correlation teach us? From this correlation analysis, we can be able to choose which are the factors that affect rental significantly. One, we see accessibility having a significant relationship. You can see accessibility having a significant relationship with monthly rental. We can see space, services, state of repairs. All these are having significant relationship. When we look at the tenant nationality, it doesn't matter, or tenant gender. Gender does not determine price. So gender has no influence on the rental income. So also is nationality. So it is not your national that determine the rental. But these are the factors that are determining the rental value are, from this analysis, is state of repairs, services, space in square meters, and accessibility. 4 factors out of 8. So these 4 factors are the factors that are affecting monthly rental. This is saying that from this correlation we can decide and try to remove other factors because they are not having significant relationship. The ones that are having significant relationship are telling us they are the determinant of rent. So what it means is that if your distance to the CBD is even short, if there is no good accessibility to that distance, it will affect your rent. So distance is not affecting rental income, rental value if the accessibility is good. What it means is that wherever you stay, no matter how far you are, if your accessibility is good, you can easily access the center from there. Then it's its accessibility that determines the rent, not even the distance. It's only when the distance is not good and the accessibility to that place is not good that you can now. So this is telling us that accessibility is more important than location itself, or than the distance to the location. So accessibility is of more importance than location and the distance between the property and the CBD. But it's showing that if there is easy accessibility to navigate around, multiple choice of communicating, of commuting to your property from the center, that will determine your rent. So accessibility is more important than the distance. That is what this correlation is telling us. Is that clear? Class?
Clear.
Okay, good. Now, you know, we are going through this again because we want to do regression, right? And because we want to do regression, a multiple regression, where more than one factor is affecting a dependent variable. Now, from this explanation, let's assume that rent, our rental income, monthly renter, is now our dependent variable. If that is our dependent variable, what factors now are now going to be the determinant variable or predictor variable? From this correlation, we can now select what factors are really affecting renter. And this has been identified by their significant contribution. So we now, from here, we now discover that accessibility, space, that is the size in terms of space, services, and state of repair are the four elements that are really determining the monthly renter. Did you understand how that factor are selected? Hello? Do we understand how this variable can be selected now? The variables that are of significant contribution to a dependent variable are the determinants. They are the independents that affect the dependent. Can we understand how we can select variables of relevance now?
Yes.
Okay, good. Now, if that is understood, then we have gotten our dependent variable, which is monthly renter, and we have gotten the four factors that are critical to determinant of a monthly renter for a residential property. So now what we need to do is that if they are acting jointly, what is the level of contribution of each one to the monthly renter? And that is what regression can give us, so that we will be able to predict. We will be able to predict a renter value for a property in any location based on these factors. So just a quick glance, we can see there's not much difference between what the parametric and non-parametric gave us. Accessibility is there, which is still a factor that is significant. Space is equally significant here. It's flagged. Services is equally significant. And state of repair is equally significant. So But when we know that our data are non-parametric data, it's better we use non-parametric correlation. That is just the difference. Now, let's now try.
Doctor,
yes.
Can I ask what is the meaning of the star? They got some data got two stars. Some are.
The star, remember, when we go to when we do analyze, remember, when we analyze and we say correlate, bivariate, yes, you see this mark, flag significant correlation. Okay? So when you tell SPSS to flag significant correlation, what it would be done is that when the output come out, correlations that are significant are given star star, meaning that SPSS is flagging them to let you know that these are the significant relationships. These correlations are significant. So that is the essence of the star. So when the star is 1, the correlation is significant at p less than 0.1. When the stars are 2, it means the correlation is significant at p less than 0.5. So when it is 3, it could be p less than 0.005. So, but normally our confidence level is about 95%, which is 5% error. So when the error is less than 0.5, it is significant. So the essence of the star is just a flagging of significant correlations, so that when you are looking for which one is significant, you will quickly see them. Is that all right? Does that answer your question?
Yes, but doctor, I just wondering what does the tail mean? Why 2 tail or 1 tail?
1 again?
There's 1 tail or 2 tail. What does that mean?
The first column, doctor.
Okay. The first column.
Kayun asked about what does it mean for the 2 tail in the bracket there.
Okay, this one correlation is significant at the 2 tail. Okay, the 2 tail, let's look at it from here. From this table, correlation is significant at the 0.01 level, 2 tail. So what this one is saying that when p is less than 0.01, it is 2 tail. That is why you have 2 star. Okay? And let's look at our correlations. Which one has 2 star? Which one has 1 star? All of them has 2 stars. I think there should be one that is 1 star. So if the correlation, that's why the meaning is, if the correlation is significant at points p less than 0.1, that means this p-value that's 0.00000 is less than 0.001. So if it is less than 0.05, it will be 1 star. Let me see if there is anyone that has 1 star here. 0.49. Okay, look at this one. Can you see this cell? Accessibility versus income. You can see it has 1 star. So the correlation is significant at 0.05 to tail. So this is number of star shows at what level is the correlation significant. Yeah. So having selected our factors, can we run a regression to see what will the regression output look like? Regression. Okay. Can we run a regression? Time is fast spent to do well. So, is there any other question there?
Doctor, last question for me. Just now you have mentioned that you compare the two factors, right?
Yeah.
We see whether which factors has higher correlation.
Yes, you look at what the correlation between the factors, which one is significantly affecting the other.
So can you repeat one more time? So how should we determine by looking to data?
Okay. So when we look at this, the essence of the correlation is to know what is the relationship between the variables, relationship between one variable and the other. And for example, our interest is the rent that the property is bringing. So we now try to look at what is the relationship between the rent and all other factors. For number one, rent to rent, the same thing, it does a perfect correlation. Because you cannot look at a relationship between rent and rent, but you can look at the relationship between rent and other factors. For property location, location does not show a significant relationship. What it does means is that the contribution of location may not really be significant on rent. Though, but good location, when the location is good, that is when your rent could be good. But this exercise shows that location has no positive contribution to renter. This is the particular data we are using. You know, it is not the real data from the field. It's just a computed data. Now, for number two, for the distance is contributing negatively to the monthly renter. That means when the farther your distance, the lower the rent. However, the coefficient is too small. You can see the coefficient is too small, 1.7%. And it is not even significant. You can see the P value is far higher than 0.05. So what it means is this: the distance to the central place contributes negatively to the monthly renter as expected, but the contribution is not significant. It's too marginal. It's a marginal contribution. Very, very, remember, weak correlation, moderate correlation, strong correlation. Now, when we get to accessibility shows a significant correlation to the rent. So that means, since it is significant, it is a determinant. And when we look at the coefficient, which is 2.8, so that is 28%. So accessibility is a determinant of monthly renter. Okay? So also, when we get to space is equally contributing. The bigger the space, the more you pay, positive. Also, accessibility is positive. The better the accessibility, the higher the rent. You know, they are direct relationship. When the accessibility is fantastic, then the money goes up. However, the contribution of space into the monthly renter is about 68%. What it means is that it has a strong correlation, and strong and significant, that you cannot do away with. We cannot just neglect. So also is services. When the services are excellent, the better the service, the better the rent. It's still equally positive. State of repairs, you know, the decoration of the property, when you look at the property, how neat it is, how modern and everything, equally contributes strongly to the monthly renter. So this gives us idea of which of these factors are really, really contributing to renter. So the significant one and they even have a strong correlation, not a weak one.
Doctor,
Yeah.
can I conclude that the more star the result have, then the
more
stronger
significant.
the relationship,
The
the
more
stronger the correlation?
No, there may be this the more star is not the answer. The star is only showing significant at particular level. What it means is that, you know, what is written here is correlation is significant at 5% when it is 1 star. Correlation is significant at 0.01% when it is double star. What this one is saying is that if your confidence interval is 95% confidence level, the significance will be at 1 star. But if your confidence level is 99%, what does that mean? The 99% means that you are sure 99% this is accurate. At 99% accuracy, you will get double star. But at 95% accuracy, 1 star. It's just a level of confidence interval that the star is indicating.
Okay, understood. So when we want to make sure that which factor should we pick up, so we choose the result that which has the star. So we can say that these factors are affect the variable, right?
Yes, because the star shows that they are significantly affecting the variable.
Okay, understood. Thank you, doctor.
So now that we have chosen this one, let's quickly do the regression so that we see how multiple regression looks like. We did linear regression last time and it was just a straightforward thing, yeah? So let's now look at this. We have now said, instead of using all these 8 variables determining the rent, we have discovered that only 4 of them have significant relationship. So we want to regress to find out what is the contribution of these significant factors on rent. So we can go on analyze, then we go on regression, linear, and when you get to this level, SPSS will ask you for which one is the dependent variable. For our exercise, monthly renter is the dependent because the rent is depending on the other factors. Is that clear? So we put monthly renter, which is our rent, on the dependent variable column. So SPSS will equally ask us, which factors are we considering as independent? So we look at our factors. What are the factors that we have identified? We have identified accessibility, access, we put it here. We have also identified space in terms of size, we put it there. We have also identified services in terms of facilities, we put it inside. And we also identify repairs, the state of repairs of the property, we put it inside. So these 4 variables are the one having significant relationship with monthly renter. So we really want to know what is their contribution. So let's check if we need to take any statistics. Estimates, model fit, yes. R square change, no, R square, we just need R square.
Doctor, meaning that we need to do the correlation first, so we can then we only can proceed to the regression, right?
Yeah, the reason why you do correlation is to know, for example, we have 8 factors, okay? Does it mean all the 8 factors can go into regression? So where there is need to know which factors are really affecting, you do correlation. For example, if you are just giving 3 factors, you may not use correlation to screen them. You can just put the 3 factors into regression. But when you have so many factors, like 18 very different factors, correlation will tell you which one of these factors, according to your data, are really the determinant of the dependent variables. So this will help you to narrow down the number of factors to put into your regression. Is that okay?
Okay.
Yeah. Thank you. Maybe R square change, if there's any R square change. We don't need the Watson here. This is parametric. So we can say continue. We just choose estimate model fields so that then regression coefficient will be given to us. Then confidence interval, yes. At what level of significance? This is confidence interval. Normally we use 95. So 95%, okay. Continue. So anytime you are ready to run, you click OK. So let's look at, good. This is our regression. This is the output from our regression. So what do we need? We need to look at the table one by one. Dependent variable, monthly rental. All requested variables are entered. This one satisfies the entry. No variable has been removed. All the variable we specified has been inputted into our analysis. Now let's look at the model summary. These are the things we look for. Model summary shows that the R square, because we need R square, it has a mini, and we need the significance level. So what this one is saying is that all the factors we have entered, they are significant, jointly significant, and justly affecting the dependent variable monthly rental. So significant level shows you that the model has created a significant relationship. There's the regression is significant, meaning the factors are significantly contributing to the dependent factors. If we want to know at how much percentage, so we use at R square. When you look at R square here gives us 0.798, which is almost 80%, 79.8%. What does it translate to? What it means is that all the 4 factors we have put into this regression are contributing 80% to rental. So that means if for for changes in this factor, there will be 80% effect on the renter. So that is the meaning of R square, because you need to in reporting the regression, your reader want to know if this contribution is large or small. What does that translate to? That means the other factors that we have screened out, or the other factors that has not been considered in this regression, are responsible for the remaining 20% contribution. Do you understand that model summary now? Do we understand what the model summary shows us? It tells us 2 things. One, that the factors are contributing about 80% to rent. 2, that the 80% contribution of all these factors are significant. They cannot be ignored. Is that okay?
Doctor, the factor you mean is all the factors you just you key in just now, right?
All the 4 factors we key in, which is state of repair, space, accessibility, and services. So these 4 factors from our data, these 4 factors are contributing 80% to the rent.
Doctor, you say 80% is referred to the R square, right?
R square, yes, that's 79.8.
Okay.
And 79.8 is almost 8%. That is 0.798. which is about 79.8, right? And that's about 80%. So what we are saying is that these 4 factors are contributing about 80% to renter, to property rent or accommodation rent. That is what our data is telling us. And the question is, what about the remaining 20%? Which factors are contributing 20%? So all other factors that we have not considered, both the one we have in our table, in our data, and the ones that are not in our data, all of them are contributing 20%. And one of such factors, if I can tell you, is household income. You know, we did not put household income into our data. So household income can determine rent, theoretically. So we can say that these 4 factors we have considered are contributing 80% to the rent per month for accommodations in maybe in Kuala Lumpur or where we have studied. You know, we have not studied, our data does not cover the whole Kuala Lumpur, or we just pick some points. So we can say that 80% of rent income is determined by these 4 factors. That is what the model summary is telling us. Do we understand that now?
Okay.
Any question from any other person? Any other question? Are we all okay with that model summary explanation?
So far, okay.
Good. Now, so let's go to even our analysis of variance equally shows significant. Now, coefficients. You know, when I talk about beta value, we are talking about coefficients. We now want to know by how much is each of these factors are contributing to the model individually. Individually, how much more of these things are being, or how much is each factor contributing? So if we want to do that, we look at the coefficient of standardized beta. When the model has not been standardized, there is always going to be an intercept. Remember, y is equal to a plus bx. There will always be an intercept, and there will always be an error level. But when the model has been standardized to take care of the error, the intercept and the error level are off. That is why you can see this beta, standardized coefficient of beta. You can see there's no error. Under unstandardized coefficient, you have error of each contribution. But when you have standardized, you don't have error and there's no intercept. So the equation comes in from standardized coefficient. Now, if we look at accessibility, the coefficient is 0.27. Can we see it? 0.027 rather. 0.027. Then when we look at the space, the beta is 4.88. When we look at the services, the beta, which is the coefficient, is 0.208. And when we look at the state of repairs, the coefficient is 4.69, 0.469 rather. And all of them, except accessibility, become insignificant. Can you see? All of them, except accessibility, become insignificant in a joint and in a joint contribution. When we look at the correlation table here, where we have accessibility, can you see accessibility here with 0.049? So okay, this 0.0419, 049 rather, you know, this is a very, very, very slight significance. It's just minimum, so the level of significance is so small because supposing this is 0.05, it will not be significant, you know, but it was just the significance level of the contribution was just, how can I define it? A string line. It was at the boundary. So you can see that the regression now shows actually whether it is really significant in the relationship or not. And here you can see it is no more significant when the real factors are put into shape. This is to show that it was a narrow significance level we have at the correlation time. And that's why I quickly make a recall to that. However, when we want to write this equation, let me see if I can copy this table. I want to copy this table. Copy. Let me put it somewhere so that we can see how we are going to write some equations there. Yeah. Okay, let me just duplicate this. I'll just duplicate this. I hope I copied it very well so that we can paste. How do I paste? Can I paste like this? No. How do I paste? No. Let me go and copy. This is not the best way to copy it. I want to copy it as a table. What is this? Copy. Copy. How do I lower bound? Okay. No. I want to copy like this. Does this look like a table? Third. Coefficient. Okay, there's a way of copying this thing. Oh. But let's go, because I want to explain how we are going to write this equation, the regression equation. Since we have accessibility now contributing 2.7, that's 0.27, then we write an equation like rental income is equal to 0.027 of accessibility plus, because they are all positive, 0.488 of space plus 0.288 of services plus 0.469 of repairs. So let's go and write it. Let me write it somewhere you'll see it. So I just want to write the equation from the Look, let me write the equation here. So from this, our exercise, we have gotten a regression equation, which now tells us that rent, which is our y, equals 0.027 of accessibility, which could be our x1 plus 0.488 of what? 488 of space. Let's say space SP, which is likely to be our x2 plus 0.288 of services, SR, which is our x3 plus 0.469 of repairs, RP, which is our x4, which is our input 4. Now let me just try and shift, which is subscript. Okay. Then subscript 2. Subscript. Okay. Subscript. Subscript. Okay. And subscripts. Subscripts. Okay. So let's reduce okay. Good. So this will be our regression line taken from the equation y equals b x1, x2, x3. Let me just copy one. bxn or bxi. So where I equals 1 to n. So what I'm trying to realize is this. We have identified these 4 factors: the accessibility, the space, or the size. I think let me use the size in terms of space, size. Then the services in terms of facilities, and repairs in terms of state of repairs. This is how this one has been contributing. The R square, that's R raised to power 2, is equal to 79.798, which is 79.8% contribution. Significant at P less than 0.05. So these are the factors. Now, what it's saying is, what we are trying to say is now is this, that all these factors are contributing 80% into income Y. And this is the level at which each of the factor contributes to the 80%. So this is the level at which each of this one contributes to the 80%. So this is plus, so not equal to. This is plus. Plus. So this is the equation that shows that we can deduce from the regression we have done. It tells us that accessibility contributes just 2.7, this contributes 4.8, and this contributes 2.8, this contributes 4.6. So this is the way these four factors are affecting income. So any other factor that is not considered here could be responsible for other 20% contribution to the income. Is that okay? So, and this is, so this table, the model summary, and this coefficient table are much more important when we are reporting regression.
So, doctor, meaning that correlation is to narrow down the factors.
Exactly.
And then
where
the
there are
coefficient, and then the coefficient is distribute the factors that which already narrow down, we make it into percentage.
Yes, yes. It's just the coefficient is talking about percentage contribution to the factor. For example, when we look at the us as students, and when we want to see the determinant of our CGPA, the accumulative, what are the factors? One, we need to attend class, right? Class attendance, so that when you are taught, at least you hear something. Two, you have to do assignments. These are the way what they are being used to assess us. We have to do test. We have to do exam. We have to do our reading. Apart from assignments, are doing tests and exam. Reading, we hate our performances in all other areas. So all this could maybe some do practicals or studio work. So let's say all this contributes to our grade. So the question now is, what is the contribution of assignment to the grade? What is the contribution of the test? What is the contribution of the exam, especially in form of assessment? You know, we tell you that the test is so percent, assignment is this, exam is this. So it is just the same way we are looking at what each of these factors are contributing to our rent. Is that okay? Yes. Are we okay with this?
So far, okay.
Yeah. I will screenshot the model summary and the coefficient so that I will add it to the slide. And possibly maybe I'll do the same thing for the data so that because you don't have SPSS, if you have SPSS, I can forward this one to you on SPSS format so that you can see it again. But maybe I will screenshot and put it on the slide. I think that is okay.
Doctor, can you send this file also? Some of us got this SPSS.
Yes, for those of you who have SPSS, I can send both the data and the outputs. And for those who doesn't have SPSS that will need to look at this table again, I think I can screenshot and put it in the slide. Would that be okay?
Yes, doctor.
Okay. So if that is acceptable, I will do that too. Yeah. I'll add it to the slide and reload, or we'll upload the slide so that you'll see the changes. Any other question?
No.
Any other question? Are we okay with this? So I've told you in regression, the coefficient matters, the significance, and the R square, the contribution. So these are the things that are reported to justify what regression we are doing and the model fits. Because, for example, if in exam a regression result is pasted and you are to interpret what the result is about, you have to look at the R square to know what is the size of the contribution of the factors of regression. You have to know the level of significance, and also you have to know the coefficient of each factor. That's the level of contribution of each factor to the dependent variable.
Doctor.
Yes.
Next week we will have our break, right?
Yes.
So after next week, we will have one test for this subject.
We have one test, one big test for this subject.
So Doctor, which day will we do the test?
I think week 7, right? Is it week 7 or week 6?
If not mistaken, it's week 6.
If it is week 6, we will have it week 6.
Tuesday or Thursday?
I think Thursday will be better so that we can meet on Tuesday before the test.
So what should we prepare?
Prepare for statistics.
All right, Doctor.
Does that answer your question?
Yes.
Okay. Well, we can prepare for. It cannot be more than the time for the tutorial. So I don't think it's something that will take all the time, but at least we cover substantially, maybe more of descriptive.
Doctor, please be lenient to us.
No, maybe more of descriptives. I will not be hard. I'm not a hard person, no. So any other question? So I think we should do it week 6 so that week 7 we can look at whatever the performance is in the test. So, and give some other tips before I hand you over to Sir Abdugani. I think that is better. Week 6, Thursday. We can do a kind of refreshing ourselves, revision ourselves on Tuesday before the test on Thursday. And the week 7 we should look at the test and see what it looks like. So generally, this is the way we apply statistics. One of the ways we apply statistics in real estate. What do you want to determine? So we can do prediction, we can forecast, we can look at an average, we can determine expected returns from any investment if we are given data. So from the data, from the known data, we can predict the unknown, and our prediction could be as good as accurate as possible so that there will not be too much divergence from our predictions. Thank you, everyone. I've almost spent 2 hours. I still have some review to do. If there's no more question, please mark your attendance on Spectrum, and you may leave the class as we close the class. If there are no more questions, if you have questions, you can still ask your question.
Doctor, should we know what ANOVA or Z-test?
You know, Z-test, all these, yes, maybe we'll discuss it more on Tuesday. Okay, on Tuesday, yeah. But you can read more about it. It's just to test for hypothesis. Depending on what hypothesis you are testing for. You know, there will be a statement of hypothesis. You can say, maybe we'll say the income is not affected by distance. You can put that into test. You know, depending on the statement of hypothesis, what we want to know. And the data that were given to us, we take care of both the dependent and independent, and you can make a test. So if it is significant, it's just about knowing whether to reject hypothesis or to accept. If the hypothesis is significant, we reject the null hypothesis, because most of the time null hypotheses are stated in negative form. So if this hypothesis says accessibility does not contribute to rental income, so when you want to do test, set test or t-test, it will ask you for dependent variable, which dependent is not, is independent. And when you put the two in, it tells you you are looking at significant value. If it's significant, you reject. If it is not significant, you accept the hypothesis. Okay? Hopefully we will set, remind me again, set test, t-test, f-test. ANOVA is f-test. So f-test. So that we can demonstrate it. Now that we have some data, we can use the data we have here to demonstrate it. Okay?
But doctor, just now your situation is like the accessibility. The correlation shows that the accessibility is significant. But during the regression,
when you see it narrowly significant, you know it's almost 0.05.
Yeah, it's at the boundary. So should we accept this as a factor?
Yes, it can be. It's at least on the correlation, it shows it's a factor. It's only that on the regression, it shows the contribution is low. Okay?
Okay.
That's the difference between the two. In the correlation, it's a factor. Because of that significant level, it's a factor. But when you put it in regression, you are looking at its contribution, not relationship this time. So the contribution is low. It's lower than the others. You can put it, you can only explain it that in the correlation, yes, it is narrowly significant, which shows that once it is significant, it shows that it's a factor that cannot be neglected when determining the rent. However, in this contribution, the contribution through the regression shows about 2.70%. Okay?
Thank you, doctor. All right.
And it does not affect the joint significance of the whole four assets. Thank you. Class, any other question? Are we okay? So if there's no more question, this is, I think between 5 to 10 minutes time, your attendance may close. Mark your attendance, inspect room, and